Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2021 Fall 10B Problem 13 and it deals with geometry. I hope you guys enjoy this video and let's get started. The problem states, a square with side length 3 is inscribed in an isosceles triangle with one side of the square along the base of the triangle. A square with side length 2 has two vertices on the other square and the other two on sides of the triangle as shown. What is the area of the triangle? So what I'm going to do is I'm going to split the triangle down the middle. Okay, and then now I'm going to quickly label the points that we have. So this is A, B, C, D, E, F, G. Okay, so the reason why I'm doing this is because I want to create some similar triangles, because we know that the side length of this is 3, and then the whole side length of the smaller one, of the smaller square, is 2. So if I split it down the middle, then that means that this is 3 halves, and then this is 1. But then we also know that BE right here, this is 3 halves as well. And then CF is 1. So we see that we have 3 similar triangles here. We have triangle GCF, GBE, and GAD. These are 3 similar triangles by angle-angle similarity. And that's because they all have a right angle. And they all share the common angle AGD. So I'm going to first look at the 2 smaller triangles, triangle GCF and GBE. Okay, so because these 2 triangles are similar, then that means that the ratios of their side lengths would be equal to each other. So what I mean by that is, for example, we have CG, which is this length right here. This length over the whole length of GB. So the length of the longer side of the smaller triangle over the longer side of the larger triangle is equal to CF over BE. Well, we know that CB is 2 because that is the length of the side length of the square. So then we can express GB in terms of CG plus 2. So we get CG over CG plus 2 is equal to CF, which we know is 1, and then BE, which we know is 3 over 2. And then I'm going to cross multiply. And solve for CG, so CG would be equal to 4. So now we can figure out the height of the triangle AG, because we know that AB is 3, and then BC is 2, and then we just figured out that CG is 4. So AG is equal to 4 plus 2 plus 3, which is 9. And then we can do side ratios again to figure out what AD is, because once we know AD, we can find out the area of the whole triangle. So I'm just going to use the smaller triangle CGF again. So CG over AG is equal to CF over AD. So CG we know is 4, AG we just figured out is 9, and then CF we already know is 1, and then we are trying to figure out AD. So we just figured out that AD is 9 over 4. So now we can solve for the area of a triangle, which is 1/2 base times height. So we have 1/2 base, which would technically be this whole length right here. So we know that AD is 9 over 4, so it'd be 9 over 4 times 2, which is 9 over 2, and then times the height, which is AG, which is 9. So it will technically just be 9 times 9 over 4, which is 81 over 4. And that would be equal to 20 1/4. So the answer is B, 20 1/4.